Welcome to Eliminate. Here we are going into the statistics part where we will discuss type 1 and type 2 errors. If you see the last sessions on statistics where we have covered confusion matrix, we discussed about false positive, false negative, true positive, true negative. When it comes to type 1 and type 2 error, the comparison is drawn here and we'll be in a position to understand both are same, type 1 and type 2 error or the confusion matrix false positive or false negative. So in this context, let us learn more of a statistical type 1 and type 2 error discussion, looking back at what we have learned in false positive and false negative. This will make us very clear in understanding statistically what is the significance of error and how to decide on which error is to be considered as the important one. So let's start with the comparison first, a summary of the confusion matrix that will give us a ground to understand type 1 and type 2 error better. So here in the last confusion matrix we have seen true positive, that is the predicted ones, positive, okay, negative predicted ones, the actual condition where we say true positive, here's a positive, here's a negative, so here's false positive, here's false negative, here's true negative. So this is what we discussed on previous session, that is true negative, true positive, this is the correct identification, and two wrong identification, false positive and false negative. Now let's move on to type 1 and type 2 error. What are they? So when it comes to a type 1 and type 2 error, we'll have to first understand the basic hypothesis. Where does this type 1 and type 2 error come in? When does we use these? The context remains the same. It's a classification problem, as we have seen here. This is used in a classification problem. Here even the hypothesis is nothing but a classification problem where we have two hypotheses, that is H0, that is the null hypothesis, then we have the H1 or H dash, that is alternate hypothesis. So these are the two things that we have to understand first. What are these? Null hypothesis normally is nothing has changed, so there is no change, everything is same, remains same, no change. So that's the null hypothesis in most of the cases, no change. There is some change, that is alternate hypothesis, there is some change. For example, if you are saying on global warming, so the temperatures say a year ago and maybe now have increased, so it was say 32 degrees Celsius or something, and now it has raised to 34 degrees Celsius, 2 degrees centigrade it has increased. So this is what is the claim. So what is this known as? This is a claim. So a scientist or someone who is doing the test is claiming that we could see 2 degree rise in the global temperatures. Now what we'll do, the basic thing will be, we'll take sample from different locations, whatever the criteria is, and based on that sample of a year ago past and the current temperature, the past data and the present data, right? Maybe we'll decide on taking averages, here average, here an average, then we'll compare whether this past temperature, average temperature before is actually less than the average temperature after. So this is a one-to-one comparison. Now you might have collected a lot of data, but at the end what are we doing? They are interested in checking whether the temperatures have actually gone up, right? Whether the temperatures have actually gone up here in the present situation. So what this becomes is a classification problem again, right? We are classifying by saying that the temperature before and the temperature after have changed by more than 2 degrees Celsius or at least greater than equal to 2 degrees Celsius. This is what is a claim, the present temperature. So there is no change. What is the null hypothesis here? Null hypothesis again, is nothing but no change in temperatures. So this is no change in temperatures. So what is alternate hypothesis? Alternate hypothesis, the temperature has increased by more than 2 degrees Celsius. Till now, we have discussed what is null hypothesis and what is alternate hypothesis. So we'll continue with the same example of global temperature increase. This is our case study. So we'll continue with this case study. So our null hypothesis is there is no change in the temperature, no change in temperature, average temperature or temperature. And our alternate hypothesis is temperature has increased by at least 2 degrees centigrade. So this is our alternate hypothesis. So this is the two things that we have to remember. Now let's switch context. Now let's go to the type 1 and type 2 error in respect of this classification problem, that whether it's classified as a null hypothesis or we go with the alternate hypothesis. So based on this classification, let's switch context and now draw the confusion matrix once again. So we had positive, or in this case we can, let's write positive and negative first. Positive, negative, this is what we are predicting and this is what is our actual. This is how we have learned in classification as well. So positive and negative. Now these are all predicted things: predicted positive, predicted positive, predicted negative, predicted negative, right? Then we again write it as true because this and this matches. P and N, that's false, so FP, here's FN, and here is true, T positive, true negative. So these are the four conditions that we have already seen in a classification problem, a standard classification problem outcome, right? So these are the two important things, false negative and false positive, that gives us the picture of how we are deciding. Now the same applies here as well. FP is nothing but our type 1 error and Fn is nothing but your type 2 error. So these are the two errors, type 1 error and type 2 error. Let's now discuss in detail what does this tell us. So type 1 error, what is type 1 error? Now from a positive aspect. So type 1 error, when is this type 1 error made? So we know now that false positive is your type 1 error and false negative is your type 2 error. Now we'll have to pay utmost attention here to understand the details of type 1 and type 2 error in context of this classification problem that we have already dealt with. Okay, so here let us take positive. Positive is what we have to understand first. What is positive for us? In context of this false positive, true positive, false negative and all, we are just taking the P part of it, the positive part of it, right? Positive. The positive outcome here is nothing but the scientist or the data analyst who is performing the test. He has set a hypothesis. That is nothing but the alternate hypothesis. Always what we set is our alternate hypothesis, right? Null hypothesis, there is no change as such. So we are setting the alternate hypothesis. So alternate hypothesis says that the temperature is increased at least by 2 degrees Celsius. So this is what is positive for us, because what we claim is correct. This is our claim and this claim is justified by our hypothesis testing. So this is our claim. The global temperature has increased by 2 degrees Celsius. Okay, so this is positive. Now what are we saying here? Just understand one thing so that the other thing becomes easy and very clear. So we'll understand false positive, that is type 1 error. Okay, type 1 error. So we are saying that the temperatures have increased by greater than 2 degrees Celsius at least. So greater than equal to 2 degrees Celsius increase in temperature was there, increase in global temperatures that was there. That is what we are saying, that is predicted. or the test is saying that this has happened. But then what is the actual condition? It is false. So the claim that we are making is not correct, it's false. Claim is incorrect. So we saying that temperature has increased by at least 2 degrees Celsius is not correct, is false. This is the type 1 error that we are making. When we are saying that the temperature has increased by 2 degrees Celsius and actually it has not. So that's type 1 error. So now take a little time. Now let me switch the context to null hypothesis. So if you say this type 1 error in terms of null hypothesis, okay, what have we done? We have rejected null hypothesis, isn't not? So we are saying that it's increased by more than 2 degrees Celsius. This is what we are predicting, positive, right? That means we have rejected null hypothesis. Rejected null hypothesis when it is not to be rejected, right? When the null hypothesis was not to be rejected, actually we had rejected the null hypothesis. So this part of it, this is what is false positive. This is the error, type 1 error that we are making. Now let's move to type 2 error. So type 1 error we have discussed. We had the null and alternate hypothesis that no change in temperature and at least 2 degrees Celsius increase in global temperature. So this is what we are claiming. We as data scientists or data analysts, we are claiming that this is what has happened in recent years, right? This is a claim. So we saw that in type 1 error, we have null hypothesis. We are rejecting null hypothesis when it should not be actually. It should not be. Okay. Now let's see type 2 error. That is false negative. So the opposite of it, that means negative is what we are saying there is no change in temperature. No change in temperature. We had claimed there is change in temperature. Now negative we are saying there is no change in temperature. Okay. When it is again not correct. Not correct to say this. When it's not correct to say that there is no change in temperature. That means if I convert this in terms of null hypothesis again, no change in temperature means that is null hypothesis, correct? So we are saying we accept or fail to reject. This is how statistically we say it, reject null hypothesis when the temperatures actually increased by at least 2 degrees Celsius. So the temperatures did actually increase by 2 degrees Celsius, but we failed to reject null hypothesis. So this type of an error, chances of making this type of an error is known as type 2 error.